Welcome back. Second part of the workshop. As promised, we will now talk in more details about gRPC and implement a sample service or multiple sample services using C#. Any questions from the first part that I didn't answer? Any open things where my descriptions weren't clear, discussions that you had during the break that we should discuss together? Nope? Good? Nice. So, then let's go into more details about how this stuff is implemented. Because many of you don't have a lot of C# background, let me quickly, very quickly, just a few minutes, show you around this project so you get an idea how C# works in that area. The generated code is really very, very small. The first thing that you have to understand if you are new to ASP.NET Core, an ASP.NET Core application is just a console app, nothing more. You don't need a heavyweight server, nothing like this. So if you would like to start this gRPC server, all you have to do is run it and it will run as, and you can see it here, main method, just a console app. It will run and that's it. So it starts, runs, that's it. Nothing special, you can run it everywhere. It runs on Linux, Windows and Mac. It runs in a Docker container. You can deploy it with .NET. You can create platform-independent, self-contained executables if you don't want any prerequisites at all. It's pretty simple. ASP.NET Core is really, really simple. ASP.NET Core, in that respect, it knows a lot of tricks, but just running it is just running a console app. It knows dependency injection, logging and all this stuff, but that's not the topic for today. If you take a look, everything starts in an ASP.NET Core application in the so-called startup class. You see here the startup class. And here we have two important things when you want to run gRPC in .NET. First thing is this one, add gRPC. Add gRPC says add all the application services that are necessary for gRPC to dependency injection. That's dependency injection configuration that we do here. It's just a call, add gRPC, and that's it. Of course, add gRPC receives a lot of options, optional options, where you can configure details about how gRPC works. But in the simple cases, to be honest, in many cases, the default options are fine. The second one is this down here. This down here will register our gRPC service into routing, endpoint routing. So here we just say we have a service called greeter service. That's all we have to do. Greeter service was generated by the ProtoBuf compiler. Okay, we'll take a look at that in a second. And the beauty here is that in ASP.NET Core, you can add here, or you can add here, your RESTful web APIs as you wish. You want to add a bunch of REST APIs, or you want to offer the same functionality as a REST API and a gRPC service, absolutely no problem. They really work nicely together. It's just ASP.NET Core, and you add the gRPC services that you like. Nothing special. We'll take a look at the service implementation in a second. First, I would like to show you the project configuration. Fortunately, it's very small and clear. In ASP.NET Core 3, you don't need a lot of so-called NuGet packages. To be honest, I have no idea about Java. Java is really not my world. But I think there is something which is called Maven, right? Is that a package manager? I think there is something like that. NuGet is what Maven is to Java, or NPM to JavaScript, or GitHub to Go, or pip to Python, or whatever. This one just says, I want to implement .NET Core App 3. I want to do web development, and please include all I need for gRPC. This down there, this gRPC ASP.NET Core, is all you need to run gRPC inside a web application with .NET. It's a so-called meta package. What does that mean? If we take a look at this package in NuGet, in the package manager, here it is, then you will see it has dependencies on the ProtoBuf runtime, google.protobuf, the ASP.NET Core server, which is just the server implementation, and the gRPC tools. This is the compiler. This is the integration of the ProtoBuf compiler into Visual Studio. But to be honest, you don't need this information. Just install this package and everything's fine. The second thing that we see is this line, and this line is really important. It just says, hey Visual Studio, there is a Protofile, please generate whatever I need for it. That's it. The ProtoBuf compiler that we saw before with Visual Studio will pick this Protofile file up, and in our case, it will generate the server code. This was the generated file that I showed you before. That's all you need to do. So these are just 1, 2, and 3 files that you need to do. Then, last but not least, we have the Protofile, which is compiled to C#, and then we have a base class, something like this, from which we derive our own implementation from. Good? So, click here, and this is the derived class. We can delete a lot of code. It looks a little bit complicated, so let me get rid of the things that we don't need. That's essentially it. That is all we need. Method, reply, request, and that's it. Now, for those of you who are not that deep into C#, what's that task all about? That's the so-called async programming model in C#. So what we could do here is we could do asynchronous stuff. Asynchronously doing I/O, accessing a database, accessing files, accessing the network, whatever. Task enables us to do that. But to be honest, we wouldn't absolutely need it, but in reality we always use any kind of I/O, so it's a good thing to have that. So, nice. Well, in reality, you might consider moving this Protofile into a library. What we can do, we already learned that the Protofile is compiled into a C# class, right? So couldn't we do that and compile it just into a class library, into a so-called DLL, a dynamic link library, and then reuse the same DLL on the server and on the client? This would be somewhat nice, because then we don't need to copy Protofiles around, we don't need to write it 2 times for client and server. That's really the thing that I really like to do, is putting these Protofiles into a class library and then just having a class library that everybody can have a dependency on. And if I change it one time, everybody can work from there. If they don't like my class library, they can always take the Protofile from me and, for instance, generate their Java client with their specific tools. I don't care. But if we have a C# client and we have a C# server, why not offering a class library? And this is the first change of this project that I would like to do together with you. If you want to follow along, it's not absolutely necessary to follow along, but you can if you want. Please right-click the solution and add a new project to our solution. There we choose the class library. A class library, I think the name is clear even for those of you who don't know C# that well. And I will call it, how did I call the first project? Beyond REST gRPC library. Okay, just a name. And then you get a class library. This class library is based on .NET Standard. .NET Standard is, I don't think, does anybody want to know what .NET Standard is? For those of you who have .NET know-how, you should know it. If not, for those of you who are not that deep into C#, it's correct. The correct version that you have to enter here is 2.1. Please change that. That's the only thing that we need. I will not go into details what .NET Standard is. If you want to know what .NET Standard is, check out my YouTube library. I have an endless number of descriptions about that. So it's .NET Standard 2.1, and we can remove this class. Now what I can do, I can take this Protofile and just move it up. Drag, drop, that's it. So I moved the Protofile here into my class library. And of course, I still would like to compile it. And this is a very important takeaway that you should take with you. If we have a Protofile, we need to compile it, and we can just go here. And unfortunately, as you can see here, there is no ProtoBuf compiler. There is none. That's true because we have to install it. In C#, it works like this. We have to install the gRPC tools. That's the tools that contain the ProtoBuf compiler using our package manager. So what I do is I click on Manage NuGet Packages, right-click, Manage NuGet Packages, and then look for gRPC.tools. You don't need to remember that. In the GitHub repository that I will provide you, you will find all these things with links directly to NuGet and GitHub and so on. So you don't need to write that down. Stay focused. Either you follow along on your own laptop or you follow along in your mind watching me on the video beamer. You don't need to write that down. That's the important message here. So we install gRPC tooling. Let's do that. Good. Now, let's take a look at the C# file, and you see here we have the gRPC tooling. Okay? That's the ProtoBuf compiler. If we now click on the Protofile, we should, if I didn't do something wrong, see the ProtoBuf compiler here. See that one? That's a very important principle of the new world of C#. It's different. Maybe you have taken a look at C# years ago, and there everything was somehow baked in Visual Studio. That's no longer the case. All the compilers, the C# compiler, the ProtoBuf compiler, everything comes from package management. So if you need a compiler, you get it from package management. If you want to update something, you update the packages. Everything is dependent on the packages in NuGet. And in our case, we get the ProtoBuf compiler, which turns, remember that, Proto into C# from NuGet. If you work with Java, I don't work with Java, I'm very sorry, then you have to get the ProtoBuf compiler for turning Protos into Java from somewhere. Okay, I cannot tell you from where, but you will find it out probably. ProtoBuf compiler, and now you see here the ProtoBuf compiler takes over. And as I told you, you can generate the server or the client, or, and that's the important thing, you can generate both if you want. So what you can do is you can either write both here or simply remove that one because the default is it generates both. Then we have a class library containing the server and the client. Thumbs up, that's exactly what I want to have. Because then both parties can use the same library. Get the idea? No? Let's try to build it. See if I broke something. Yes, that's fine. I know I broke something, but this is by design. The compiler already picked up everything, but the problem is if I take a look at this one, you see this is the generated file. Can you remember I told you about the generated file? It contains some things that it needs at runtime. Because the compiler generates code, and that code needs at runtime some libraries. And we need to install the necessary libraries again from NuGet. Right-click, Manage NuGet Packages, and from there we install two packages. First, we need general gRPC port in C#. Therefore, we install the, it's not hard to guess, gRPC package. It contains everything we need for gRPC in C#. That's all. Just one package. Good? Once we have that, we have learned that gRPC builds on top of ProtoBuf. ProtoBuf also needs a runtime, and this runtime is called google.protobuf. This is the runtime for protocol buffers. So the takeaway for you is gRPC needs a compiler to generate the code, and at runtime we need support for gRPC and protobuf. And that's it. Just three includes. If you can't remember that, it's in my slides, and it is also in the documentation where you could have just copied this 3-line out. But, well, I wanted to show you step by step how it works. Good, let's install this thing. Now again, let's take a look at the C# project. This is how it should look like. We have ProtoBuf support, we have gRPC support, and we need the compiler. That is the 3 things that we need to do. Let's build it again. And you see, build succeeded. Hooray! We now have a class library containing everything we need for ProtoBuf. Please make sure that you understand what I mean here. It's just the proto files. It's not the implementation. The implementation is in the ASP.NET Core library. It's just the Protofile compiled into C# code. Get it? We could put that on NuGet, and then we could have multiple implementations of this service, or yeah, whatever. The client takes this library, the server takes this library, everyone is happy. Questions so far, or is that clear? Good. So with that, we can delete the Protofile from our server project. We have it here, so we no longer need it here. We already have library. So delete the Protofiles. That's it. And also, we can delete a bunch of NuGet files. If you take a look at the server, let's see. Oh, no, everything is fine. Everything is good. We now just need a dependency on the library. So, for those of you who are not that familiar, right-click on the project. Sorry, right-click on dependencies. Sorry. Add reference, and click on the library, because we reference the library with the Protofile from our implementation library. Get the idea? That is what we do. And with that, we should still be able to compile everything. Yoo-hoo! That's exactly what I wanted. And now I have a nice design here. I can gather all my Protofiles in a single project. They generate client and server code. Whenever I need to implement a service, I just reference this NuGet package or library and override a bunch of virtual methods. Whenever I want to call this library, I just need a reference on the Beyond REST gRPC library and I'm done. I immediately get everything that I need. Compare that with the workflow with a RESTful Web API. With a RESTful Web API, you might also sit down and write a Swagger file. Are you all at least a little bit familiar with Swagger OpenAPI? Anybody not? So you know approximately how it looks like. If you want to know a lot of details, come to my talk tomorrow. But compare that with this one. This is really simple, right? Compared to a Swagger version 3 file, it would be much longer. But still, you would write the Swagger file, and then you could generate the server from it. Probably you don't want to do that because the generated code isn't good. You would write the server code by hand. Then you could generate the client from the Swagger file. You could do the same workflow, but it's way less integrated into the whole development workflow. This works much better, and it's much clearer and much more straightforward. You don't have so many options. You have clear guidance. You have one compiler, which is maintained from Microsoft directly. You don't have 7 different open source projects that generate code like with Swagger. So that is a big advantage compared to REST APIs. Good? Good. Nice. Now let's add a client, right? In our simple scenario, we will add a command line client. So right-click on the solution and we will add a third project. A simple console app, nothing special. Let's call it Beyond REST gRPC Client. Good. In order to have the client, we need a dependency again on our library. So server references this guy, client references this guy. And I would like to make that very clear. We don't absolutely need to do that. Imagine that the server was implemented in Java. Then we cannot reference a class library. Then we would just take the Protofile and embed it directly in our code. That's fine. Maybe the authors of the gRPC service published the Protofile on GitHub. I will show you later on how you can directly reference protofiles from GitHub and import them into your project. That's really simple. It's really not difficult. Okay? In our case, we have the same language on the client and on the server, so we can share a common class library. That's fine. As a C# developer, I'm used to run C# everywhere. C# runs on mobile apps, on mobile clients, it runs on different servers, it's just a console app with WebAssembly, it even runs in the browser. Wherever you can run a .NET Standard 2.1 library, you have full gRPC support. Unfortunately, not in the browser. We know limitations of the browser. But everywhere else where .NET Standard 2.1 is, gRPC is there. Good. Now the client needs a NuGet package because gRPC, the client gRPC, also needs some runtime support. So I go to Browse and add a reference to the gRPC.NET client. That's just the client runtime for gRPC. Only the client runtime, not the server code. We want to keep our client small and tiny. Yep. Looks good. So you see, here we have a dependency on the client, and we need, right-click on dependencies, a reference to our class library. We have discussed that before. Good. We are ready to go, and we can call our simple API. Let's do that. The first thing that we have to, a main method, I think everything knows what a main method is, so I don't need to describe that one. The first thing that we are going to create is a channel. Equals to gRPC channel. For those of you who are not that familiar with Visual Studio, if you use a class name that it doesn't recognize, then you get this red squigglies, and then you can use this light bulb here, see that one, to generate the so-called using statement. Using is just a reference to the namespace. If you want to have the keyboard shortcut, if you're not familiar with Visual Studio, Control dot will give you exactly the same. So Control dot enter, and you have the using statement up here, and it suddenly knows the name of the class. And there we can say we want to talk to a gRPC service, which is hosted on HTTPS. TLS is mandatory for gRPC. You have to explicitly opt out if you don't want to have gRPC, if you don't want to have SSL protection for your gRPC services. Many gRPC clients don't even allow you to opt out from TLS. The .NET client allows you to do so. Somebody asked you, I think you asked me, or somebody asked me in the break, I don't know who it was, concerning Mac. The Mac and TLS is somewhat difficult, but in our case it's fine because we can use SSL for localhost, and by default ASP.NET Core listens on port 5001. That's just the auto-generated way. From that we can generate the client, and this is now our specific client. New. Let's take a look in the proto here. You see, this one is the package greet, and it's in the namespace beyond REST gRPC server. So let's say new greet. We need a using. To make this very clear, this is the namespace from the Protofile. This is the name of the service. Greet the client, and we give it the channel as a parameter. This gives us now a typed gRPC client on which we can call methods. Please note that the channel should be reused. So if you have multiple gRPC services running on the same server on the same port, then always use the same channel. The channel is the thing that uses more or less a lot of resources, but having a client is really something very lightweight. Okay? So you can have multiple clients, that's not a problem, but you should just have one channel per RPC server with which you communicate. Now we say client dot, and you see, good, say hello async. This say hello async exists because we have an RPC which says say hello. So we get immediately IntelliSense and all the things that we are used to. We also get IntelliSense. It says, I want to have a hello request, and I will give you a hello reply. Well, create the request first. Hello request. What are the parameters here? Just a name. My name is Rainer, but you can add your name, of course. And then, because it's an async method, for those of you who want to follow along, let's make this guy async task. And last but not least, put an await in front of it and say var result equals 2. So I will wait until everybody could follow who wants to follow. The important things. Async says, I want to do async network communication. It does not block the calling thread. This is important when you have a microservice to microservice architecture. Because if you would use blocking I/O here, then your microservice web server will not be scalable. Get the idea? Because every blocked thread is blocking a thread on your web server, and you only have limited threads. So therefore, you want to free the thread for the time that the gRPC communication is going on. Therefore, rule of thumb, always use the async methods for gRPC. That's important. Then your service will be really scalable. Good. And the result, as you can see it here, contains a message. And this message, again, is from our Protofile. This is the message that we want to have. So from 10,000 feet, you could say, okay, that is nice because now I have a typed client that generates all the stuff that I need. I never need to think about HTTPs, headers that I have to add and so on. Everything is really nice typed with IntelliSense, just as you specified it in the Protofile. So let's print the message, result.message. Good. And with that, we can try everything. Just 3 lines of code. If you want to try it, the easiest thing is to right-click on the solution and select Set Startup Projects. This one. Because with that, we can say, Set Startup Projects, please run the client and the server whenever I press F5. That means Visual Studio start both projects with a debugger attached, so I can set breakpoints on the client and on the server just as I like. Understand what I mean? Please don't make one mistake. I see that mistake commonly. Many people, when they start working with .NET, they have learned about NuGet packages and structuring your application in class libraries and microservices. They start ripping across everything. And immediately when they create a new class library, they put it into a NuGet package and so on. Wait for that. A single solution with multiple projects in it is really great while developing the basic stuff. Once the stuff has been matured, you can rip it apart into different NuGet packages. But this, having everything in a single solution, at least at the beginning or while learning, while exploring the technology, is really a big advantage. I know this is a monolith here, but monolith is good as long as it doesn't become too large. So, hit OK and press start. And if I didn't make any severe mistakes, we should see a server coming up. Here the server. And we should see a client, and I didn't make a lot of mistakes. We called our first gRPC service, and it says hello Rainer because that is the message that we sent back. And if we take a look here at the server, really nice, we see that gRPC integrates nicely into .NET Core's logging middleware. So we see we got a request on the say hello endpoint, and we executed the response, and it took, I don't know, in the debugger, 199 milliseconds. That's okay for the first request. It's much faster later on. It's debugger and on my local machine where it records the session and so on. So it's really, really fast. But the meter communication here, it plugs in nicely into all the stuff. If you have, I don't know, logging, a central logging service and so on, it's automatically logged just as you like it. Okay? So that was simple, right? Let's go. Any questions so far? Question, please.
I don't seem to be able to find the greeter client. I've got a greeter beta client.
Okay, if you got the this one, the greeter client, if you just find the greeter client, then you probably have not removed in the CS proj file the generation of just the server. So just to recap that, on the server, in the Protofile, here, oh, I will show it to you here in the UI. I have a nice UI, why not showing it? Here, previously we had server only. See that one? And maybe you have that one. And you should say either client and server, or you just remove the whole setting because the default is client and server. And with that, you should generate the client. Did it solve your problem? Yeah, you can check it. Other questions? Even though, yeah, question.
You showed where you had to specify the IP address and the port for the client. Did you show that as well for the server?
Good question. If you take a look at ASP.NET Core, we see here that we are using the so-called web hosts default, the default web host builder. And the default in ASP.NET Core is localhost, port 5000 for unencrypted connections and not relevant for us now, and port 5001 for encrypted connection. So that's just the default. Can you change these settings here? Definitely you can. You can change it here, and you can change it via environment variables. So for instance, in a Docker container, you would probably set an environment variable if you want a specific port. You shouldn't hard code the port for the server in your code. It should be a configurable setting from a settings file or an environment variable or something else. Does that answer your question? Good. Further questions? So I would like to bring everything on the table, even those of you who are not in the C# world. The workflow is the same. Write a Protofile, send it to the compiler, generate server and client, implement the methods on the server, and immediately you get a typed client. That's always the same workflow for all languages. And that is one of the big advantages of gRPC. Good? Good. Did it solve your problem? What I told you about the server and the client, or not? Just a second? No problem. No problem. I have to take a look at my notes, what the next step is. Is there. Okay, very good, very good, very good. So let's add a little bit of more advanced stuff to our Protofile. Or first, talk a little bit about the Protofile. If you want to learn a lot about the Protofile, you should definitely check out the language guide for Google ProtoBuf. It can be found here. The link is in the GitHub repository that I showed you before, so you don't need to write that down, but it's really easy to find. Just Google for Proto Language Guide. Please use version 3. Version 2 is not recommended anymore. So, simple thing. This is a simple message that you see here. Every message contains fields. These fields can have either very basic data types. I will show you a list of data types in a second. Every field has a name, as you can see it here. This will be consumed by the language compiler. It will generate a property or a field or whatever the language understands. And now comes the important part. Every field also has a number. It's important that this number is unique. The ProtoBuf compiler will complain if you reuse numbers. Why? Internally, when it does a binary serialization, it does not use the name of the field. It uses these indexes. And it uses a very compact form of serialization. So therefore, you should use lower index numbers for fields that occur frequently. If you have optional fields, the field number should be, for instance, higher than 16. Because then the system needs 2 bytes to encode the field number. If you use the field numbers 1 to 15, it can encode the field number into a single byte, and therefore you can save space. This is the kind of optimization that's going on in ProtoBuf. You don't need to use all numbers, so it's perfectly fine to have you have field number 1, 2, then a gap, and then 16, 17, 18 for optional fields. That's perfectly fine. Because later on, you can add some additional required fields which only need a single byte for the field number. Get the idea? If you delete a field from a Protofile, then you must never ever reuse this ID in the future again if you want to be able to decode an old message. For that, there is a special keyword in Protofile which says reserved. Reserved means don't reuse this number anymore. We used it in the past, and we must not use it in the future. Get the idea? Well, if you are just doing network communication and old protofiles, old messages are not relevant anymore, then you can, of course, reuse the numbers. But if you saved something, for instance, in a database or a file, and you would like to be able to deserialize this stuff in the future, reserve field numbers if you delete the fields. Okay? Important one. So, you now know the difference between names and numbers. Messages, we will see later how that works, can also be hierarchically structured. So you can have a message type as a field in a message, just like with JSON. In JSON, you can have an object containing a field, which is an object, containing a field which is an object. Same is true here. So instead of int32 result something, we could also say, again, message, name of the message, and put it into a field. So we have messages inside messages, like the Russian dolls. Field types, you have a lot of scalar types. It doesn't make sense to walk you through all these different supported data types. You have a nice table, as you can see it here, where you see what is the prototype and what types are generated in which language. So for you, if I got you right, many of you are Java developers, maybe this column is really important for you. For me, as a C# developer and a Go developer, these 2 columns are really important for me. Yeah? So if I scroll down a little bit, you see a lot of different numbers, number formats, and so on. And of course, we have string and arbitrary bytes. Get it? Good. If you want to know all the details about how this stuff is encoded, take a look at here, but this is really only relevant for people who are implementing protocol buffers in a separate language. Maybe you have a kind of domain-specific language and you want to implement that on your own. That's a very interesting project. I envy you, but yeah, it's only relevant for very few people. What else can I show you? Let me see. Yeah, of course, comments. These are the reserved fields. I already talked about the reserved fields. What is generated? We saw that one. Yeah, enumerations are important. Enumerations are really frequently used. And as you see, you can define an enumeration here with enumeration values, and then you can use this enumeration inside of your messages. Okay? That's an important one. But I think it's kind of obvious how it works. What else do we have? What else? Yes, here we see multiple things which are interesting. You see a message, and this message is part of another message. This is the thing that I told you before. So in this case, we define a message type, which is called result, and that result type is included into search response. And the interesting thing here is that we have a modifier here that we have to talk a little bit about. In a Protofile, a single field can be repeatedly used. Get the idea? So you can repeat a field. It can also be optional, it can be required, and it can be repeated, as you see here. So then you will get an array or list or whatever the language supports. At a certain point in time, your protofiles will become pretty large, and then you can structure them into multiple files. This is not just relevant because you structure your protofiles on your own, but in practice you will often reference protofiles of other people. For instance, Google has defined some protofiles where they specify standardized message types for translating error information. If the gRPC service says, oh, something bad has happened, you shouldn't think about your own message structure of how the client gets this error information, but you should just take Google's standardized messages and standardized enumerations for error codes and so on. So this is very relevant, and you will use it in many applications, and we will use it in a few minutes in our application too. Question.
How does the numbering works here? For example, if you have, if you are using another protofile which are using the ID 1234, and if you import it in your project, in your protofile,
okay,
can you reuse 1234 or?
Excellent question. These field numbers must be unique inside of the message, and you cannot import a different protofile and extend a message. That's not possible, but you can embed it. So if you use in your protofile, in your message, let's say it's your message 1234, if I want to consume this protofile, I can embed your message in my message, and in my message I can use 1234 if I want, because this 1234 is just must be unique inside the message. Get the idea? So the answer is yes, you can reuse these indexes. So yeah, nested types, that's essentially the same as before, just directly nested inside the message. You can write it this way or that way. Nested as deep as you want. Let me see if I want, yeah. Any and one-off are the last two things that I would specifically like to talk about. Any is interested, you see, repeated any details. The nice thing with any is that you will get just byte arrays in your client. So if your Protobuf message contains some blob where you don't care about the details, you can use any. Or maybe this blob is again another Protobuf encoded message, then you can first get it as an any and then use again the Protobuf runtime to decode this any byte array with any business logic that you like. But any can also be, I don't know, a picture or an embedded piece of music, video, whatever you want. Okay? This is any. And last but not least, and one of the most important ones in real life, is one-off. Please take a look at this example. The sample message is one-off string or submessage. So you can say this message contains either this or that, not both. It's an XOR I'm talking here. Okay? You could, for instance, use that to return either a valid result or error information. You get the idea? That's this one-off. And inside your own code, you can then use, for instance, a switch statement or an if statement to find out, do I have this one or that one? And then you can process it accordingly. This is one-off. Get it? So don't use any if you have a situation where you have, I don't know, kind of indicator. Is this, I don't know, a customer order or an invoice? Use one-off in such cases. Good? And again, this can be used as embedded fields. You can use the sample message with a repeated field and all this stuff. So all the things apply that I told you before. Good? We will use one-off in our example in a few minutes. Nice. Please make sure, if you want to go into the details, to read the rest of this, this language specification at home. For instance, you have important information about backwards compatibility. You have some guides here on the left-hand side about how to write good protofiles, a style guide, and many other things. Please take a look at that. I only have 1.5 hours for gRPC. I can't go into all the details. But the documentation is really good. It's not that complex. I think in a few hours, you have read everything and you have a good overview. From me, you get a kind of, let's say, survival pack, and you have an idea whether it makes sense to take a closer look here. Do you have any specific questions before we try to apply a bunch of these things in our sample? Yes?
I read again already default values and null types was
this one?
yeah.
Default values are similar to C++. So if you don't specify anything, then for instance, a string is an empty string, a byte is an empty byte, 0, bool, default false. I think you get the idea.
Yeah.
Good. Further questions before we apply this in our example? Yes?
What kind of validations we can use on these properties which we are specifying in Protofile?
About what?
Validations.
Validations?
Yeah, if you want to validate a field that, for example, this string cannot be more than 10 characters, or it can be.
Doesn't apply here. You have to do that on your application level, on the application level.
Okay.
Yeah. ProtoBuf does not restrict you here. Yeah. Also things like date and so on, you have to come up with your own thing. Do you encode a date as an ISO string, or do you encode it as a Unix date time, whatever, that's up to you. Yeah. Okay, good. Let's apply this in our small example, and therefore we are going to extend our Protofile quite significantly. Now, it doesn't make a lot of sense if I type a lot, so I have prepared, of course, this example. So if you like to follow along, I invite you to go into my material, and I will show you in a second where you have to go. Here in the gRPC shared, yes, here we are. This is the file where you have to navigate to. Just open the folder github.com/r/stropek/samples, and there navigate into the folder beyond REST. Then you have a second time beyond REST. Then you have gRPC shared, and then open greet.proto in your browser. We will just copy paste some lines so that we can spend more time discussing the code instead of typing the code, okay? Did everybody get the URL who would like to follow along? Okay, good. Good. I would like to add the MathGuru. This MathGuru does the following thing. We will focus on the first method first. It can generate Fibonacci numbers. We get a parameter from2, so a range in which we would like to get Fibonacci numbers. And the interesting thing here, let's first take a look at the message. I mean, this is trivial, from2. The result is also trivial. It's just and int 32. But the interesting stuff here is that one. That is specific for gRPC. We return a stream of numbers, because in my example, I thought just calculating Fibonacci numbers is just kind of boring. We will simulate a more complex calculation algorithm. So in our application, we will, between each Fibonacci number, we will wait for a bunch of milliseconds, and we will stream step by step the results back to the client. And the only thing you need to write here is just stream, and that's it. It's really powerful. If you build an asynchronous communication, that's really interesting. Think of an IoT scenario where you get some sensor values streaming from the device, the robot, the machine, back to your other microservice where you want to do some intelligent data analysis. This would be typical scenarios where you could use such a streaming application. Okay? In this case, this is just server to client streaming. So I would like you to copy this part. You can also copy the rest, I don't care. But for now, you just need this part. And let's put it into our Protofile. No, I'm sorry, I have to, you cannot copy this one currently. We will need additional stuff in order to compile that. So please do not copy the last part. I forgot something here. Good. We can just compile it, and it will generate the necessary code for us to create the second. This one, I told you we'll focus on the first one. This one can also be deleted currently. So that is the code that we need to copy. Good, compile it, it should compile. At least in my case, let's take a look. Yes, completed successfully. Nice, build succeeded. That's exactly what I wanted. With that, we can start to implement our service. And for that, we go into services here and add a new class. First, we will start with our super complex mathematical algorithm. Let's call it math algorithms. Math algorithms. If you want to type, feel free to type, but it doesn't make much sense. We can copy it from our gRPC server. Here, services, math algorithms. See, this is the thing that we need. This class is what we need. Math algorithms. It's really, really simple, and I will walk you through this code in a second. That's it. It's a kind of trivial Fibonacci algorithm. If you're not that familiar with C#, let me walk you through the code. This means this method returns a list, a collection of integers. IEnumerable is the base interface for all collections in C#, for those of you who are not that familiar with C#. Then I'm using two helper variables, previous and current. It starts with 0 and 1, and have an endless loop. Then I'm just calculating, for those of you who cannot remember from math classes what Fibonacci numbers are, it starts maybe with 0, but I will start with 1. Then we have 1 with the first 2's, and the next one is the sum of the previous 2. So 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 5 plus 3 is 8. 5 plus 8 is 13. 13 plus 8 is 21, and I think you now get the idea. Right? Just so that we can remember what Fibonacci numbers are. And this code, it's really trivial. It's just doing an assignment of two values. Then the previous value, now the current value becomes the previous value, and the next value becomes the previous value plus current. This is what we do here. And in C#, we know something which is called a so-called enumerator block. Yield means, in German, ernten. It will just return one value after the other. Get the idea? This is how you write that in C#. don't worry that we have an endless loop here. The yield statement will immediately return to the caller. And when the caller asks for the next value, it will generate the next value, return to the caller. And when it asks for the next value, it would return to the caller, and so on and so on. And the caller is in charge of stopping. So when the caller says, I'm no longer interested in further values, everything is good. Then the method will complete. Get the idea? So that is a very, very generic way. You don't need any parameters like a stop at number, blah, blah, blah. It really goes into caller, back, into caller, back, into caller, back. That's very old. It exists, I think, since C# 1.1, since the early days. It's a very useful feature whenever you have some value generations. Okay? I don't know if Java has something similar. I really don't have an idea, but this is pretty nice. Now we have an algorithm and we can implement our service. Let's do that. So let's add another class, this one, and this one we will call MathGuru Service. And this will now be a gRPC service. What is the base class of our MathGuru service? Well, the base class is the one generated by gRPC, right? So what we can do is we can take the class that was generated from the Protofile and use it as our base class. And if we take a look at the Protofile, we will see that the service was called MathGuru. You see it here? So let's do that. Let's go to the MathGuru and say MathGuru, see it here? It's a namespace dot MathGuru base. This base class with the abstract functions, with the virtual functions that we can override, was generated by our Protofile. Again, this Protofile generated this class. Clear? So we can just override blank, and you see this method here was generated by a Protofile. So I can simply enter, good, done. Now we can add here, we can remove the default stuff, add implementation here. That's the workflow. For me, it's more important that you, because you are not that deep into C#, it's evenly important, let's put it this way, that you understand the workflow. Write the Protofile, generate base classes, override the methods, done. Good? Good. Now, of course, I will not type everything with you. So if you want to follow along, I have a copy-paste request. Again, wouldn't it be nice to have such a service in every day? Just copy something from, well, we have Stack Overflow, don't we? So, no, of course not. You're not Stack Overflow programmers. Please take a look in this file that I have prepared for you. It's in the gRPC server, MathGuru Service. And there you have a simple implementation, get Fibonacci, and just zip, copy the implementation of this method. Ignore the get Fibonacci step by step. This will be the next step. It will be even more interesting. And in order to make it work, please write async in front of this task stuff. Good? We still have an error, I know, but we don't worry about it. Let's quickly go through the code. The first one, from to, can you remember what that came from? Well, from our proto. That's the message here. That is the parameters that we need to execute. The next one is the response stream, so we don't get a numeric result that we have to return, but we get a so-called server stream writer. Why? Because we said we want to stream values back. So we can write and write and write and write to this connection, and the client can receive these values. You get the idea? That's the big difference between our first hello world and this streaming API. Streaming is really very much different from what you know from HTTP web APIs. So Yeah, you get the third one, the so-called server call context. The server call context gives you access to all the properties of the HTTP2 connection between the server and the client. You can inspect some authentication information. You can send some advanced header stuff, so-called trailings and so on. We will not go into the very details here, but just think of more in-depth information about the connection between server and client. This is what we have here. First one, we check the parameters, and what I can show you here is that with gRPC, you can return status information similar to HTTP REST API. So what you can do, you can return an arbitrary integer value. There are some predefined values that gRPC gives you. So these values here, like aborted, already exists, cancelled, data loss, internal, not found, and so on, they haven't been defined by Microsoft. They are defined status code from gRPC, very similar to HTTP status codes that you might already know. But in this case, the values are much smaller because, oh my God, a value of 200, that needs 2 bytes. We cannot waste 2 bytes. We need smaller values. Yeah, I think you get the idea. Question?
Can you only return either a status or a result, or can you also combine?
You can also combine it. You can send status only, and you can status and payload. In this case, I decided to send an immediate error status back. Okay? And you can also, if you want, send an error message back. If that's not enough, if error number plus message is not enough, there is a defined pattern for returning advanced error information, and we'll take a look at that in the last example that is really way more powerful. But for now, remember, status codes and strings, they're already present. Then we go through the Fibonacci numbers. If it's too low, take the next Fibonacci number. If it fits to the specified value range, and now comes the important thing, stream the result back. All you do is you just say, write async, and you write back the result. So the server returns a constant stream of values. And then just to simulate some longer calculation or I/O, I'm just waiting for 250 milliseconds. That's all. Get the idea? So this is where the streaming comes in. And once we have reached the upper limit that the client gave us, we can stop executing. And if we stop executing this method, then the client understands immediately that it will not receive any more streaming results. So we don't need to close the stream or something, we just execute the method and everything is fine. Get the idea? As long as the server remains active and doesn't end the RPC, the function call, it can send and stream values. Good? Clear? Yeah. Well, the only thing that we need is we need to have our powerful math algorithm inside of our gRPC service, because we know we shouldn't implement spaghetti code, so we shouldn't mix UI, gRPC, and business logic, Fibonacci number calculation. So therefore, we have a separate class. And the reason why I did it, because I would like to show you that gRPC, at least in C#, is very nicely integrated in all the powerful stuff that ASP.NET can do. So we can easily go to Startup and use dependency injection. In reality, I would use an interface, but please forgive me if I'm not doing an interface here. I just say services.add singleton of, oops, I somehow managed to switch to English keyboard, math algorithm. Yeah. Add a using statement here. So that adds our algorithm, our business logic, to dependency injection. As I said, in reality, I would have an iMath algorithm in order to be able to do mock objects when testing my RPC service. I think you get the point. But in our case, I make my life simple. I just do constructor injection, CTOR, and I say, hey, give me a math algorithms instance. Let's call it math, and say this.math equals math in order to store it in our class. Good. Let's generate a read-only field. You get the idea? You don't need to understand the details. The meta information that I give you is that Microsoft has decided to make gRPC a first-class citizen in their ASP.NET Core infrastructure. And all the nice things apply that they have been doing for many, many years now. So all the things that you know, like logging and dependency injection and things like that, they all apply to gRPC services equally. And if you, for instance, have some business logic that you would like to expose with gRPC and Web API, you can do that because you can put both things in the same project. And with that, share the same business logic. Maybe you don't want to because you are so much into microservices and separation. Okay, but for many applications that I know, they are not that complicated. And I know a lot of developers who have medium complex business logic, and they just want to publish it in two different formats for gRPC and Web API. Why not doing it this way and use the same dependency injection behind the scenes? Okay? Good? Good. With that, we should be able to compile everything. Let's see. I tried to compile everything. Build succeeded. Good. The only thing that we need is a little bit of client code. And again, let's copy some code. Please go back to Beyond REST gRPC client. If you don't want to follow along, you have all the code. You can take a look at home, or maybe try to translate that in Java. That would be a good example. Go to Program. And the part that I'm now interested in is exactly that code. You find it in the method server streaming. I will copy it in the gRPC client program CS server streaming. I will paste it here. Now the only thing that we need is this math client. Let's create it. Var math client equals new greeter dot MathGuru client. Now, why did I write this code? Because it's super important for me to emphasize again, the channel exists once, but we can have multiple clients running against the same channel. Get the idea? So we have multiple different RPC services on the same channel. This is performance-wise the thing that you should do. Here we need a using, maybe you can remember it, control dot, which will give us the using, and then we will take a look in the code. The code is really nice, and fortunately, Microsoft has done something what I really like. In ASP. Let me give you a little bit of background. In ASP.NET Core 3, they introduced gRPC. gRPC with server-side streaming. Data streaming from the server to the client. They also added additional support for SignalR. So again, we have a protocol where the client can stream data to the server and vice versa. The server can stream data to the client. So we have very often a scenario where we receive values over and over, and between the values, we need to wait a little bit. So we have something like async streaming. And at the same time, while they were implementing these protocols, they said we have to make it simpler for developers to consume an asynchronous stream of values. Because implementing something like this isn't trivial. You have to make a loop, and inside this loop you have some async calls and all this stuff. We have to make that simpler. Well, how do you consume a value in C#? There is a loop which is called for each. It just iterates over a collection. Every developer knows that by heart. We do that every single day, thousands of times. Does Java also have a for each loop, right? Now, what is an async stream? It's just a collection, right? But the collection is not filled immediately, but it will be filled step by step by step. So what they did in the latest version of C#, which came at the same time as gRPC support and streaming support for SignalR, they added so-called async stream support for each. So therefore, we now, in the latest versions of C#, we can do that. Isn't that awesome? That's all. We just say, wait for each. And it handles, I call this Harry Potter programming. It just works. It's just a little bit of fairy dust and it just works. So we take the response stream. Can you remember? The get Fibonacci from the Protofile returned a stream. And all we need to do in our program CS is we need to take the result, take the response stream, and read from it asynchronously. And we can for each across the results, just like any other collection. Just like the server would have immediately returned all the Fibonacci numbers, but it didn't. And this is non-blocking, so it scales very well. Let's take a look if I didn't promise you too much. Let's start the application. Now this with the await for each was specific. The service is unimplemented. Why is it unimplemented? Let me quickly see why it is get Fibonacci, but I implemented. I forgot something. I'm sorry. In the startup method, you see, greet the service. I forgot to publish the MathGuru service. Let's do that. And then it should work. MathGuru Service. Run it. And nice. Did you see how the results were tripping in step by step? That's exactly the async, the await for each that we saw here. So now the Fibonacci numbers between 10 and 50 are 13, 21, and 34. Sounds reasonable? I think that's correct. Got it? Now everything you heard, nearly everything, can be applied equally to other languages like Java, like C++. Only the await for each stuff is specific to C#. But maybe it's interesting also for those of you who are not that familiar with C#. Okay? You have to use the constructs of the language you are typically using. Now if we take a look at the server, then we will see that we have all the stuff. Where is it? Yeah, here. The calls with the get Fibonacci and so on, all written to the log as promised. Good? Clear? Now if we, for instance, go to the client here, and in the client we do something stupid from 100 to 50, which doesn't make any sense because, well, 100 is greater than 50, and we set a breakpoint here. I will do that, and I run it again. You don't need to do that in your own implementation if you follow along. Just take a look at what's going to happen. Then, boom, here we are. If we take a look at the Fibonacci result here, then we will see that if I can find it, I should be able to see, but I'm not seeing it. Exactly, now I have it. You see? I need to read the first result, otherwise I don't get it. And you see, invalid argument, and this is exactly the detail that I have, and it's embedded into an RPC exception. So now I can add a try catch around this call, and I can gracefully handle any mistake that I did. Get the idea? Very similar to an HTTP client. Good? Good. Let's switch it back to 10 to 50. Nice, we are good in time. So we can start our last sample, again copying a little bit of code, but the last sample really brings everything together because it's one of the, it's the most complicated one, okay? Good. Not that complicated, but it's the most powerful one. Let's put it this way, the most powerful one. We do the following. Please, if you want to follow along, go back to our gRPC shared in the Protofile, and now we are going to copy this line and this message. And I would like to show you what's so special about these two things. The first one, take a look at the method signature. The client streams and the server streams. That is bidirectional streaming. So think of the client streams some options to the server and the server responds constantly with some kind of values. That's now really bidirectional communication between client and server over gRPC. In my case, I created it this way. I can send from two requests, Fibonacci numbers, from the client to the server. I will get back results, and then I can stream the next request and I get back results. Think of, for instance, a kind of server-side database cursor. I am scrolling through a large list of values and I'm just requesting, give me now page 15. Oh, the user scrolled up, give me now page 3. I think you get the idea. But I'm sure you can come up with more interesting scenarios for your specific domain. So that is the first one that's specific. And the second one is the result message is a one-off, as you can see here. And I'm using a package from Google RPC status, which is for error handling. So I'm consuming a Protofile provided by Google over GitHub. That's a very common thing. Maybe you work together, multiple teams, every team has their own Protofiles and you would like to consume those Protofiles. You can find it on your GitLab, GitHub, Azure DevOps, whatever server, and we would like to use them. Okay? This is what I want to achieve. So, if you want to follow along, please copy this line, get Fibonacci step by step, into our Protofile. Here. And copy this step-by-step result here. That's it. Now if I try to compile that, I will get an error. Here it is. It says, hey Rainer, google.rpc.status, I have no idea what that is. There are a few types, prototypes, that are well-known types. For instance, can you remember the any type? Can you remember that? There was the byte array where you can add arbitrary bytes in. That is a well-known type that you don't need to import. But something like this is not a well-known type. It just happens that Google wrote a recommendation how to return error messages. You can use it, but you don't need to. It's really up to you. So we need to somehow import this stuff. So what we need to get this status thing from somewhere. Good. Let's Google this. Let's Google. And let's see if we can find it. It happens that we can easily find it. It's at home in Google APIs /google/rpc/status.proto. And please now use your imagination. Yeah? We are now using a Protofile supplied by Google. But in your company, you might get this Protofile from your colleagues, from another microservice or whatever. Okay? So just to make that clear. If I scroll down a little bit, you get a lot of documentation, how to use that. Feel free to read that at home. We will not do that. And at the end, we get a single message which says, see that one? The message status contains a code, a message, and any details. You see that one? So Google recommends take an int message, take an error string, but then let the user of this structure add any error-specific data inside of this field. And the client can interpret this details stuff depending on the error number, for instance. Get the idea? Good? Good. Additionally, they say please do not just use any arbitrary integer number, but if possible, use the gRPC codes. So we need another file. It's not enough to take the status proto, but we also have the code proto. It's another file that Google provides, and we will see that it contains just an enumeration. Google doesn't want everybody to invent his or her own status number. So, for instance, if we want to return invalid arguments, we should really use Google stuff. Good? So how do we get these two files? We could simply copy-paste them. Copy-paste into our project, and that's fine. But we somehow need, wouldn't we like to have some kind of package management for these protofiles? And the package management is GitHub. So what the ProtoBuf compiler understands is that, this is the C# ProtoBuf compiler, but every ProtoBuf compiler knows that. It understands that we can reference a library that comes from Git, that comes from an HTTP URL or a file server or wherever. Okay? You have to find your specific way of distributing your protofiles. Put it on GitHub, put it on a web server, put it on a file share where everybody can access. I don't care. Something where the Google ProtoBuf compiler can access it. Good? And now I show you how this works in C#. If you want to follow along, I have in the gRPC, in this folder here, Beyond REST, course material, gRPC markdown, I have looked up the commands that you need to get the two files into your project. Referencing protofiles. So if you want to follow along, I will do it on the video beam in a second, you have to execute this statement. Then you have to execute this statement. And then you have to execute this statement. And it will download the status proto and the code proto into your application. Get it? So we just reference the files. And luckily, it lets us also refresh this stuff. So if it happens that Google has a great idea and changes its error information, well, this will not happen, but think of another microservice that's offering a Protofile, and they are updating the Protofile, and you would like to get the updated version. The only thing that you have to do is you say .NET gRPC refresh. Get the idea? That will pull down the Protofile into your project. Good? Let's try it. So, I go into Visual Studio in my class library and open a shell. I don't care if you use Bash or CMD or PowerShell or whatever you want. I really don't care. Everything works. Let's copy this guy. That is the first statement that I showed you. Okay. And then the second statement. The result is that we now, if you take a look, have these two protofiles in our shared class library. You see it here? Please note that the directory structure here follows the directory structure of the name of the package. So it was called Google/RPC/status, if you remember that one. See that one? Inside the message, we use dots instead of slashes. That's important. If the folder structure doesn't match, the ProtoBuf compiler will not find it. That's important. In the library, you will see that it just stored a reference to these files. Got it? So let's build it. One thing is still missing. Inside of our Protofile, we need to reference we need to reference Google's file, And I told you how this works. We say import google/rpc/status.proto. We already had that when we were discussing the syntax of the protofiles. Now let's compile it again. And build failed. Let me see the system. Oh, yeah. That's a trick. I'm sorry about that. The tooling that references these external protofiles, they just added, you see that one, they added a reference to ASP.NET Core to our class library. That is wrong. So the tooling tried to be intelligent, but it was stupid instead. So please delete the reference to ASP.NET Core. We don't need that. The class library is reusable not only in ASP.NET Core, it's usable everywhere. So this is wrong. Good. Still, we have some mismatch. Let's rebuild everything, rebuild solution. Rebuild all succeeded. Now it works. So I'm sorry, the tooling does something wrong here. Delete this NuGet package. That's a detail. You don't need to remember it. For me, it's very important that you understand that these protofiles are exchanged between teams. And you have to find a way of how to exchange protofiles between teams. GitHub or Git or something like this is a good thing for that. Good? Questions so far? Or is that clear? Now, what we have is we have two-way streaming, bidirectional streaming, and we are referencing an external protofile. That's good. Now we need to implement the server and the client. And it's 12:27. I already told you in the morning that I'm not sure whether we will make it to the very end of the gRPC sample in this 1.5 hours. I was suspecting that I will not be able to do it completely. I would like to not do the implementation now, because then we have to stop somewhere in the middle. It's a good thing that it is better that we now do a break. And I hope I have you on the edges of your seats that you want to see bidirectional streaming and the code. No, just kidding. After the lunch break, we will take a look at the bidirectional streaming. That's not a problem. It will just take 15 minutes or so because the code is prepared. I just want you to understand how the message flows in bidirectional streaming, and then we have time for this 15 minutes, and then we will switch gears and move to SignalR and spend the rest of the 1.5 hours with SignalR before we go into OData in the last 1.5 hours. Okay? I hope you have a clear understanding what these protofiles are, how you work with them, how the workflow is, and now you already understand the big difference in working with gRPC compared to HTTP-based REST APIs. And I also hope that you might got a glimpse into how C# works with this stuff. There were times where I wasn't a big fan of C#. I really went into TypeScript and so on. But currently, Microsoft is really on a good path by aligning the language features like await for each and so on to make modern protocols like gRPC more easily to use. I really like that. Independent of whether you like C# or not, that's a good engineering task that they did in the last years. So with that, I wish you Mahlzeit. I wish you nice lunch. I got the information that lunch is available between 12:30 and 1:30 p.m. So please be back at 1:30 p.m. and we will finish our sample. If you have any questions, please come to me. I will be most of the time here, just also grabbing something to eat. Good. See you later.